Friends, welcome to Bank Exam Cafe, and in today's episode on some applications of trigonometry, we are going to see few more questions. This is part 9. Previously we have uploaded 8 parts and the links of all these 8 parts are provided in the description box. I request you to go through all these 8 parts so that the idea of the questions that are asked in the examination that you will get and how to deal with that problems. Now here this is the part 9 and let us move to the first question of the part 9. So friends, here is the first question. The angles of elevation of the top of a tower from the points P and Q at a distance of A and B respectively from the base and in the same straight line with it are complementary. Prove that the height of the tower is root AB. This is root of AB. This type of question, one we have seen in the previous episode. It is of the same type, but still the question asked is little bit different. Here AB is a tower and there are 2 points P and Q at a distance of A and B from the foot of the tower. P is situated at a distance of A and Q is situated at a distance of B from the foot of the tower. And it is said that the angle of elevation from these 2 points Q and a point P, these angles of elevations are complementary. Prove that the height of the tower is root of AB. Now here these 2 angles are complementary. It means that the sum of these 2 angles is 90 degrees. So if you take one angle as theta degrees, then the other will be 90 minus theta degrees because both the angles are complementary. Now here we get 2 right triangles. One is APB and another is triangle AQB. With the help of these 2, we can solve the height of the tower, or we can show the height of the tower as root AB. So first we will take triangle APB. So in triangle APB, here in this triangle APB, we have tan 90 minus theta is equal to opposite side upon adjacent side. So opposite side is AB. Let the height of this tower is H. So opposite side is H. So tan of 90 minus theta, that is equal to H upon adjacent side is PB, that is A. Now tan 90 minus theta, that is cot theta. So it will be cot of theta, which is equal to H upon A. And take A to this side and you will get H is equal to A cot of theta. So it will be A cot of theta. Let this be equation number 1. Now we will take the another triangle, that is AQB. In this triangle AQB, in triangle AQB, here we have tan theta, that is equal to opposite upon adjacent. So tan of theta, that is equal to opposite. Opposite is what? It is H. And the adjacent is what? It is B. It is given as B. So H upon B. Now take B to other side. So you will get H is equal to B tan of theta. H is equal to B tan of theta. Let this be number 2. Now multiplying number 1 and 2. Multiplying number 1 and 2. We get multiplying equation 1 and 2, we get If we multiply these two equations, we get h into h, that will be h square. So it is h square, which is equal to here a into b, that will be ab, and cot theta into tan theta, cot theta into tan theta. But here if you see, cot theta and tan theta both are the reciprocals of each other, both are the reciprocals of each other, and the product of the reciprocals is always 1. Suppose number 3 is there, its reciprocal will be 1 by 3, and the product of this will be 3 1s are 3, 3 1s are 3, that is equal to 1. So the product of the reciprocals is always 1. Cot theta and tan theta are the reciprocals, so their product is 1. So we get h square is equal to ab, because cot theta into tan theta, which is equal to 1. Now we have to find the value of h. So taking square root of both the sides, so it will be h is equal to square root of ab, and therefore the height of a tower, the height of a tower is equal to square root of AB units. The unit may be whatever it may be, meter, centimeter or kilometer or anything. Now here the height of the tower is root of AB, and that only we have to prove, and hence we have proved that height of the tower is root of AB units. Now let us move to the next question. Now here the question is, there is a small island in the middle of a 100-meter wide river, and a tall tree stands on the island. P and Q are the points directly opposite to each other on the two banks and in the line with the tree. If the angles of elevation of the top of the tree from the points P and Q are respectively 30 degrees and 45 degrees, find the height of the tree, where root 3 is equal to 1.732. Now here there is a river, and the width of the river is 100 meter. Suppose P is the one end and the Q is the another end, means both are the banks of the river, and the distance between the two banks of the river is 100 meter. There is a island, and on that island there is a tree. So let AB is a tree which is on the island, and it is given that the angle of elevation, it is also given that this P, B and Q are in the same line, these 2 points and the foot of the tree are in the same line, and therefore P, B, Q are on the same line. So here it is given that the angle of elevation of the top of the tree, that is point A, from P point is 30 degree, and angle of elevation from the point Q of the top of the tree is 45 degree. Here while drawing the diagram, you have to just see that the smaller angle is to this side, or if it is to this side, then this distance should be shown longer as compared to 45 degree angle. This will be the shorter, because as you go closer to the object, the angle of elevation increases, and if you go away from the object, the angle of elevation decreases. So this angle is 30 degree. It means that this point P is away from the foot of the tree, and this point Q is closer to the foot of the tree, because this angle is greater than this angle. Now here there are the two triangles ABQ, right angle triangle, and another is ABP. With the help of these two, we can find the height of the tree. So here, friends, first we will take the triangle ABQ. In triangle ABQ, we have tan of 45 that is equal to opposite upon adjacent. Let the height of the tree be h meter. So here this is tan 45, that is opposite side upon adjacent side, so it will be h upon x. So tan 45, which is equal to h upon x. So tan 45 is 1, so which is equal to h upon x, cross multiply, so you will get x is equal to h. Let this be equation number 1. Now we will go to the another triangle, that is triangle ABP. So in triangle ABP, we have tan 30, that is equal to AB upon PB. First of all, it is given that this distance is 100 meter, and if we assume that this is x meter, then the rest of the part will be 100 minus x, because the total distance is 100 meter. The distance between P and Q points is 100 meter. So let us, this BQ is x, so BP will be 100 minus x. So here tan 30, that is equal to opposite upon adjacent, so it will be h upon 100 minus x. So tan 30, that is equal to h upon 100 minus x. H upon 100 minus x. But x is what? X is nothing but h, so we can replace x by h, and so you will get tan of 30, that is equal to h upon 100 minus h from 1, from equation number 1. But tan 30 is 1 upon root 3. Tan 30 is 1 upon root 3, that is equal to h upon 100 minus h. Now cross multiply, and you will get 100 minus h, which is equal to h root 3. 100 minus h into h root 3. Take h to other side, and so it will be 100 is equal to h root 3 plus h. Now take out h as a common factor, so it will be 100 is equal to, h is a common factor, it will be root 3 plus 1. Close the bracket. So take root 3 plus 1 to this side, so you will get h is equal to 100 upon root 3 plus 1. Rationalize this, so multiply root 3 minus 1 to the numerator as well as to the denominator, and so it will be h is equal to 100 into root 3 minus 1. 100 into root 3 minus 1. And to the denominator also we are multiplying by root 3 minus 1. So root 3 plus 1 into root 3 minus 1, that is a plus b, into a minus b, that is a square minus b square. So a square, that is root 3 square, that is root 3 square is 3, and minus b square, that is 1 square, will be 1. So h is equal to, this will be 2 50s are 100, so it will be 50 into bracket root 3 minus 1. Now put the value of root 3 because it is given to us, so h is equal to 50 into root 3, that is 1.732 minus 1. So h is equal to 50 into 0.732, and 50 into 0.732, that is equal to 36.60 meter, and therefore the height of the tree, the height of the tree, that is equal to 36.60 meter. Friends, here we have solved 2 questions. In every episode we are solving 2 questions. Up till now we have completed 10 episodes, means we have solved 20 questions. And I hope you must have enjoyed this video. If yes, please like the video, share it with your friends, and do not forget to subscribe the channel. Also press the bell icon so that the notification of the newly uploaded video will reach to you and you will not miss any of the video. So friends, like the video, share it with your friends and subscribe the channel. Thank you very much for watching this video.